Next page has acids and bases. I'm going to need my name to formula to name sheet again, only this time we're going to end up using the right side when it starts with hydrogen or you see the word acid in the name. So the stuff over here and the stuff over here, this is going to come into play on these ones. Name the following acids or bases. So first things first, I'm going to go for the easy one. There's one up there that we've always been able to do. This one. It is not anything new. It isn't one of the special acid rules. It is the base, as evidenced by the OH hydroxide. I have to look to see that Fe is iron. I have to look on the periodic table to see, oh wait, iron needs a Roman numeral. Not sure what that is yet. And its last name is going to be hydroxide because OH is hydroxide. Hydroxides are always a -1. We have 3 of them for a grand total of -3. We only have one iron. It must be a +3. I need a Roman numeral 3 there. Iron 3 hydroxide. All the rest, if I go to this page, does the formula start with H? Yes, it does. Its last name then is going to be acid. This one is an acid. This one is an acid because it starts with H. And this one is an acid because it starts with H. So the mystery will be to figure out what is its first name. The first name is going to come from its negative ion, and we have to do a little bit of investigating. I go to this, look at the first one here, H2SO3. H's are its positive ion, SO3. What is SO3? We'll find the back of my periodic table. Find SO3. It's right here in the middle. It's sulfite. Next step, sulfite. Well, when I'm looking at this, sulfite, if I was to write sulf there, becomes sulfus, S-U-L-F. So I'm going to go back to this, and I can literally write sulfus acid. Now, reality is, for sulfur, you actually keep the UR in there. Either of those will be okay for the test exam, sulfus acid or sulfurous. Which is the better? Sulfurous. Next one, I'm looking for a PO4. PO4, according to this thing, is phosphate. If I went back to here and found the 8s, phosphate becomes phosphic acid. Trying this right-handed. So I would write phosphic acid, and that is totally okay. Much like sulfur, when you keep the UR, phosphorus, you also keep the OR. Phosphoric acid is the better answer. I will not mark wrong. Phosphic. Finally, HF. What's F? Go consult your periodic table. It's not on the back side. It's on the front side. It's on the nonmetal ide side because it's just one thing. Fluorine is fluoride. What do you do with an ide according to the law, to the rules? Ides become hydro something ic. Fluoride becomes hydrofluoric acid. Hydrofluoric acid. The reverse will come into play when we're trying to name them. When we're trying to write formulas. In order to write formulas, do you see the word name to formula? Do you see the word acid? If it's yes, we have some special rules. So let me look at these ones. Hey, this one I don't see the word acid. So this is something we've been able to do just like on page 1. Nickel with a +2 and hydroxide with a -1 would be nickel hydroxide. All these ones that end with the word acid, according to this, Yes, H plus is the positive ion. So I can guarantee you that every single one of these starts with H. H, H, H. I'm going to break this up. I'm not just going to write the answer. I'm going to break it up as to how I got that answer. So I know that it's always going to be an H plus. That really means H plus 1. I just don't ever write the 1. 1 plus sign means that. H plus. How can you tell its last name? The H plus is the positive ion, but you use the acid rules to find the negative ion. You have to flip that back over to this side to see the little chart. I becomes this. So like we're going to find one. Let's see which one we're going to do first. Hydrobromic acid. If I go to hydrobromic acid comes from the hydrobromic acid comes from the bromide ion. Most of the ides, all except one, are on the nonmetal ide side. Here you'd find bromine, which becomes bromide with a -1 charge. So when I go down to hydrobromic, it's Br with a -1. That's a match made in heaven. HBr is the only thing you'd have to write for the answer. I'm just trying to spell out how you got it. How about carbonic? Well, carbonic comes from the, where's the ick? There's the hydro ick. It's not that one. Carbon ick comes from the carbon 8 ion. I won't find that on the front of the periodic table. I'm going to find that on the back of the periodic table. Carbonate is, there it is, carbonate, CO3 with a -2. So when I'm at this one, CO3 with a -2, when I crisscross, I have to remember to crisscross charges. When I go down this thing, it's going to tell me be sure to crisscross to balance the charges. Then I'm going to need 2 hydrogens to balance off the -2 in the 1, H2CO3. That's all I need to write. Chlorous acid. Let me go find the rules. Us's come from ites. So chlorous comes from chlorite ion. I don't know that one off the top of my head. Don't need to. Go find your periodic table. Search until you find chlorite. There it is, chlorite, ClO2 with a -1 charge. ClO2 with a -1 charge. That's a match made in heaven, HClO2. Calculate and explain how to make 250 mils of a 0.8 molar solution using a stock solution. Okay, so this is one where we have a solution added to another solution. So when I'm going to go find, I hope I can find, down here on the bottom, when you're doing dilutions or titrations, we're going to use the M1V1 equals M2V2, molarity and volume, molarity and volume. Let's bring that formula back over here. M1V1 equals M2V2. What am I making? I'm trying to get, I don't know if we want to, we'll call this my stock solution, and this is my new solution. So I'm going to set it up like that. I'm trying to make 250 milliliters of a 0.8 big M. That's the new stuff that I'm trying to make. I'm going to set that equal to, what am I using? I'm using 16 molar times how much? V1. I don't know how much to use. Now, to get V1 all by itself, divide by 16 molar, so that crosses off. What you do to one side, you do to the other. 0.8 times 250 divided by 16 equals 12.5 milliliters. 12.5 milliliters of that strong acid. So what's this going to look like? Need some water. I know when I'm done I need to have 250 milliliters of 0.8 molar. I'm going to use a bottle of the strong stuff, which is 16 molar. How much? 12.5 milliliters. But I need a grand total of 250 milliliters. So how much water do I need? 250 milliliters minus the 12.5 I just put into there is going to be 237.5, 237.5 milliliters. Next one down is different. I'm using a solid. I'm going to go get myself a different formula. Formula here says that molarity equals moles per liter. I should write something like this: can be changed to grams. So we're going to have to first figure that out. Here's what I'm interested: molarity, moles per liter. And I got to set it up that way. That's my round little buddy. That's my formula, that big M is moles per liter. What am I doing? Trying to make some solution. How much? 250 milliliters again. What strength? 0.8 big M. Only this time I'm using water. How much? And I'm also using a solid of calcium hydroxide. And I'm going to need to figure out how many grams, because solids are weighed by grams. Since it's a solid, it's going to dissolve. So 250 milliliters is what we need. 250 milliliters is how much water we need. Different than the one up here. This one, it was going to be a liquid added to a liquid, and so I had to subtract because they're going to add together. Solids just dissolve. So how many grams of sodium or calcium hydroxide do I need? Well, things that I do know. I do know that the molarity is 0.8 molar. I'm trying to figure out how many moles it is. I'm trying to cover this up, moles, so it's going to be molarity times liters. I don't have a choice on this liters. I didn't write this definition, so I have to use liters. So even though it says 250 milliliters, I'm going to put that times 0.250 liters because that's the formula. .8 times 250. Clear that again. 0.8 times 0.250. I've got a grand total of 0.2 moles. 0.2 moles of calcium hydroxide. Well, I've got to figure out how much 1 mole of calcium hydroxide weighs. It's 40 plus 2 oxygens, which is going to be 32, plus 2 hydrogens, which is going to be 2 more. It's going to be 74 grams. 74 grams is 1 mole of calcium hydroxide. 0.2 times 74 is going to be 14.8 grams. Last couple, neutralization reactions. Every time you have an acid and a base go together, they'll neutralize and make water and a salt. It's a double replacement reaction. The trick is to find the right formulas. Nitric acid, we've already gone through the whole acid rules, so I'm just going to write it. HNO3. Calcium hydroxide, we just saw that one just up above. I'll just steal that formula from there. It's going to, the hydrogens are now going to dance with the OHs, which is really water, but I'm going to write it as HOH. And the calciums are now going to dance with the NO3s. The thing about calciums is they're +2. The nitrates are only a -1. So it's going to take 2 of those nitrates. So I've got 2 nitrates over here. I better put a 2 over here. And if I've got now 2 hydrogens on this side and 2 hydroxides on this side, I'm going to have to 2 there. That one's balanced. Sulfuric acid. Johnny was a chemist, but Johnny is no more, because what Johnny thought was H2O was H2SO4. That's sulfuric acid. Goes with sodium hydroxide, a monohydroxic. It's going to, once again, you're going to get water, HOH. I'm going to write it that way. Once again, you're going to get a salt. This salt is Na dancing with SO4. Once again, NAs with a +1 don't dance evenly with SO4s with the -2. It's going to take 2 NAs to balance out the charges on an SO4. If I have 2 sodiums on the right side, I'm going to need 2 sodiums on this side. If I have 2 hydrogens on this side and 2 hydroxides, I'm going to need a 2 there, and that is balanced.